Let's take a look at page 2 of your seminar. Start with question 20. And does that form a triangle? 7 plus 8 is 15. That's bigger than 10. So that forms a triangle, so we can throw out letter J. That's not possible. Now we'll look at the converse Pythagorean theorem. I want to compare 10 squared with 7 squared plus 8 squared. Well, 10 squared is 100. And then 7 squared is 49. And 8 squared is 64. I do know that 100 is less than, 4 plus 9 is 13. 113. Since 100 is less than that, that makes it acute. And so F is your correct choice. Remember, when you use the converse, you always have to put the c squared first to use that converse. It'll make it a lot simpler. Now, let's take a look at number 21. I want to find the perimeter of this, but I'm missing a side. I know the hypotenuse is 12. So I'm going to say 12 squared equals st squared plus 5 squared. Remember, simplify first, so 144 equals st squared plus 25. Well, let's subtract 25 from both sides. And then we get 144 minus 25. Well, if I take 14 minus 5, I get 9. And then 3 minus 2 is 1, so that's what, 119 equals st squared. Take the square root of both sides. In fact, I think I'll just write this as the square root of 119 for now. Then to find the perimeter, we add up all the sides. So it'll be 12 plus 5 plus the square root of 119. Since it's multiple choice, I notice they're rounding to the nearest tenth, so that's what we're going to do. So I go 17 plus the square root of 119, and I get 27.9. And there's our answer for 21. Now in 22 through 25, you probably want to refer to your chart for the Pythagorean triples. Because notice they're all nice whole numbers. So if I look at my chart for, let me pull this down a little bit first. So if I go back to my seminar, look at my chart for Pythagorean triples, the one that makes a right triangle, well, that's going to be 8, 15, and 17, isn't it? How do I know that? Because I looked at the chart. Okay, now, what's going to make it acute? Well, acute would probably be the one that's going to be the closest. So I wonder if I do 8, 14, and 15. So let's do 15 squared. Let's compare that with 8 squared plus 14 squared. Well, then I'll get 225 on the left. 64 plus 196. And if I add 60, whoops, don't want to put an equal sign there. If I add 64 and 196, 6 plus 4 is 10. I'll get 6 plus 7 plus 9 is 16. and I get 260. Notice 225 is less than 260, so that would make it acute. So I'm going to say 8, 14, and 15. Now, are there more than one correct answer? Maybe. Will 14, 15, and 17 work? That might work too, but I like 8, 14, and 15. Now, let's look at the obtuse. Well, I'm thinking I probably want the biggest one compared. So how does 20 squared compared with 8 squared and 14 squared? Already know 8 squared plus 14 squared is 260, because I did that on question 23. 20 squared is 400. That would be obtuse then. So we'll go 8, 14, and 20. And as long as you show your work, you probably got it right. Because there's more than one correct answer on these. I just picked 2 of them. Okay, question 25. I've got this rhombus, and I want to find the side length. And I know the perimeter is 20, so that turns out pretty basic. I take 20 divided by 4, and each side is 5. Then I want to find the length of the other diagonal. Let's draw this in. So I've got this rhombus. I didn't draw it very well, but I know each side is 5. And I know one of my diagonals is going to be 8. And remember, when you have a parallelogram, or a rhombus in this case, I know it bisects it. So I know this one is 4 and the other one is 4. Well, since I got a right triangle here, I've got a Pythagorean triple, as it turns out. The most common Pythagorean triple is 3, 4, 5. So I know the length of the other diagonal is going to be 6, because 3 plus 3 is 6. You could have used Pythagorean theorem if you didn't recognize that wasn't a Pythagorean triple, and then you could have solved. You still would have got 3, no matter how you do it. I just saved you some work here. Okay, in 27, I want to find the value of x, which means I got to find f to b, which it doesn't look like I know f to b, do I? So let's back up, and we're going to have to do Pythagorean theorem a couple times. And I will start with my triangle here. And let me see here. No, I won't start with that triangle, because I don't know that triangle ABC is right. So let's redo that. And let's find B to D. Can I find that? Yes, I can find that by looking at this triangle here. So in that triangle, my hypotenuse is 11.6. So I'm going to say 11.6 squared equals 7.5 squared plus, we'll say, BD squared. And we got some decimals, so we're going to use our calculator quite often on this problem. So 11.6 squared is 134.56. And that's 7.5 squared. Well, that's going to be 56.25. Plus dB squared. Now, Let's subtract 56.25 from both sides. So if we take 134.56 minus 56.25, we end up with 78.31 equals dB squared. So then I'll take the square root, and dB, I think I'm going to leave that as the square root of 78.31 for now. That way I have less rounding errors. Then I will look at my other right triangle that has BD as a side, and I will solve for BC. Well, BC is my hypotenuse, so I'm going to say BC squared equals 15 squared plus the square root of 78.31 squared. So then I get BC squared. If I square 15, that's 225 plus 78.31. I get 303.31. So BC is going to be the square root of 303.31. Now, I can find FC because, let me use, here I've got F to E to C. So now I'm going to say my hypotenuse is 13. So 13 squared equals 2.7 squared plus FC squared. Well, then I'm going to say, well, that's 169 equals 2.7 squared is 7.29 plus FC squared. And then I'll subtract 7.29 from both sides. So FC squared is going to be 161.71. So in other words, FC is the square root of 161.71. So finally, to find B to C, I shouldn't say finally. So B to C is going to be the square root of 303.31 minus the square root of 161.71. Use a calculator for that. And I think I'll round to the nearest hundredth because it won't be my final answer. So we take the square root of 303.31 minus the square root of 161.71, and we get about 4.69 for B to C. Now finally, notice X is going to be our hypotenuse, so X squared equals 4.69 squared plus 2.7 squared. So if I square 4.69 and I add 2.7 squared, I'll get about 29.31. And then we take the square root and we get 5.41 is approximately what x is. And since it will rounded to the nearest tenth, I'll say it's about 5.4. Okay, question 28. Any two right triangles with the same hypotenuse are going to have the same area. Well, that's false, because I could have two triangles that have like a hypotenuse of 14. They could have different numbers to get 14. You know, obviously they'd be irrational. So that one, they could be true, but unless they have the same numbers, that's going to be false.